5.2 goes over solving systems of linear equations by substitution. So when you are doing these equations, you are going to be taking one of those equations and solving it for one of the variables, either x or y. Once you get what one of those variables is equal to, you plug the expression in for that variable in the opposite equation. You can then solve for one specific variable and then substitute that in for the other. So what does this all mean? For example A, in example 1, we have y is equal to negative 2x minus 9, and 6x minus 5y is equal to negative 19. With that first equation, you already have y solved for. When that happens, you can just take that expression and plug it in for y in the second equation. So you're going to have 6x minus 5 times what y equals, which is negative 2x minus 9, is equal to negative 19. You can distribute that negative 5 to give you 6x plus 10x plus 45 is equal to negative 19. From here, you're going to combine your like terms. So the 6 plus 10 gives us 16x plus 45 is equal to negative 19. From here, you're going to solve for x. So subtract the 45 from each side. You have two numbers that are the same signs. So you're going to keep the sign and add the numbers. The 9 and the 5 give you 14. 4 plus 1 is 6. So from here, we can divide each of these by 16. You're going to have x is equal to a negative. 64 divided by 16 gives us 4. So x is equal to negative 4. You still have to solve for y. So you have to take this negative 4 and plug it in for x in your first equation. So you have y is equal to negative 2 times x, which we found was negative 4 minus 9. The negative 2 times negative 4 is 8. 8 minus 9 gives us y is equal to negative 1. Now you have x is equal to, you have y is equal to, so make an ordered pair out of these two. If x is equal to negative 4, y is equal to negative 1, that ordered pair, that's your solution, is negative 4, negative 1. For example B, we're given y is equal to 3x plus 14, and y is equal to negative 4x. Both of these equations, your y is equal to something. So you can literally set the two expressions, that 3x plus 14 and that negative 4x, equal to one another to solve for x. So we're going to do negative 4x is equal to 3x plus 14. I'm going to move that 3x over to be with that 4x by subtracting it from each side. We have negative 7x plus 14, or sorry, negative 7x is equal to 14. We then divide each side by that negative 7 to get that x is equal to negative 2. We have an x is equal to, I'm just going to underline this to keep it in mind that I have an x value already. So now I have to solve for y. I can pick either of these two equations to solve for y. I feel like my lesser amount of steps is that y is equal to negative 4 times x. So I'm going to plug that negative 2 in for that equation. So I'm going to have y is equal to negative 4 times x, which is negative 2. The negative 4 times negative 2 is 8. So y is equal to 8. I now have an x and a y. So my answer is just this negative 2, 8. You want to remember with these, you're working with ordered pairs. So x comes before y. For example C, we have 3x plus 2y is equal to 0, and y is equal to 1/2 x minus 1. One of these equations is already solved for a variable, so I'm going to use that 1/2 x minus 1 to substitute in for y in my first equation. So I'm going to have 3x plus 2 times y, well, y is 1/2 x minus 1 is equal to 0. I'm going to distribute in this 2 to give myself 3x plus 2 times 1/2 x is just x minus 2 times 1 is negative 2. I'm going to combine my like terms. The 3x plus 1x is 4x minus 2 is equal to 0. From here, I'm going to add that 2 to each side, and I get 4x is equal to 2. From here, I'm going to divide each side by that 4, so x is equal to 1/2. Again, I'm going to underline this so I know that I already have an x value. From here, I need to still solve for y. So I'm going to take this and plug it in for y is equal to 1/2 times x, which is 1/2 minus 1. The 1/2 times 1/2 gives us 1/4 minus 1. That 1 as a fraction is the same thing as 4 over 4. So y is equal to 1/4 minus 4/4. 1 minus 4 is negative 3. So y is equal to negative 3 over 4. I have an x, I have a y. So my answer for this one is 1/2, comma negative 3/4. For example D, we have x is equal to 6y minus 7, and 4x plus y is equal to negative 3. So for this one, I now have an x is equal to. So I'm going to take what x is equal to and plug it in for x in my second equation. So this 6y minus 7 is going to go in for x in the 4 times x plus y is equal to negative 3. So I'm going to just take this, plug it in for x here. So 4 times 6y minus 7 plus y is equal to negative 3. I'm going to distribute this 4 to start with. I get 24y minus 28 plus y is equal to negative 3. I combine my like terms to get 25y minus 28 is equal to negative 3. I then add the 28 to each side, and I'm going to be left with 25y is equal to 25. Then we divide each side by that 25 to get y is equal to 1. I have a y is equal to, I'm going to take that and plug it in to solve for x. So I have x is equal to 6y minus 7. That's going to be the easiest one to plug in for. So x is going to equal 6 times 1 minus 7. 6 times 1 is 6, so x is equal to 6 minus 7, which gives us x is equal to negative 1. I now have an x and a y, so my answer is just negative 1, positive 1. If we look at our next set of examples, these equations do not have a variable that's solved for. So we're going to have to pick one of them to solve for a specific variable. If we look at example 2a, we have negative x plus y is equal to 3, and 3x plus y is equal to negative 1. I'm going to choose that top one, that negative x plus y is equal to 3, and solve this equation for y. So I move my x over by adding it to both sides, and just out of habit, I write x plus 3 instead of 3 plus x. So I'm going to take this x plus 3, and I'm going to plug it in for y in the opposite equation. So I'm not going to do it to the same equation. I'm going to do it to the other one that I haven't worked with yet. So this is going to give me 3x plus y, which is x plus 3, is equal to negative 1. I combine my like terms to give myself 4x plus 3 is equal to negative 1. I subtract that 3 from each side. I have 4x is equal to negative 4. And then I divide each side by that 4 to get x is equal to negative 1. Now that I have what x is equal to, I'm going to plug this into one of the other two equations that I have, either the y is equal to or the negative x plus y is equal to 3. I'm going to plug it in to the y is equal to. So I'm just going to have y is equal to x, which is negative 1 plus 3. The negative 1 plus 3 is 2. So I have a y value of 2 and an x value of negative 1. So this gives me my solution of negative 1, 2. For b, we have x plus y is equal to negative 2, and 3x plus y is equal to 6. I'm going to solve the first equation, that x plus y is equal to negative 2 for y. So I'm going to subtract that x from each side. I get y is equal to negative x minus 2. So I'm going to take this and plug it in for y in my second equation, since I have not worked with that equation yet. So I'm going to have negative 3x plus y, which is negative x minus 2, is equal to 6. I rewrite this so that way I don't have a plus and minus next to each other. So it's just going to be negative 3x minus x minus 2 is equal to 6. We can combine our like terms to give ourselves negative 4x minus 2 is equal to 6. Then we can add the 2 to each side. We would have negative 4x is equal to 8. And then we divide each side by that negative 4 to get that x is equal to negative 2. If x is equal to negative 2, we are going to take this negative 2 and plug it in for x to solve for y now. So I'm going to have y is equal to negative x, which is negative 2, minus 2. Two negatives turn into positives, so y is equal to 2 minus 2, which is y is equal to 0. Now that I have a x is equal to and a y is equal to, I can make my ordered pair of x comma y, which is just going to be negative 2 comma 0. For example C, we have negative x plus y is equal to negative 4, as well as 4x minus y is equal to 10. Now I'm going to take this first equation, this negative x plus y is equal to negative 4, and because my y value is already positive, I'm going to keep y by itself and just move the x over by adding it to each side. So I'm going to have y is equal to x minus 4. I'm going to plug this x minus 4 in for y in my second equation, since I have not worked with that one yet. So this is going to give me 4x minus x minus 4 is equal to 10. Be careful with this. As you can see, I kept my x minus 4 in parentheses because I have a negative in front of it, which means I'm going to distribute in that negative to both terms inside that set of parentheses. So I'm going to distribute that negative. I'm going to be left with 4x minus x plus 4 is equal to 10. I can combine like terms to give myself 3x plus 4 is equal to 10. Then I'm going to subtract the 4 from each side to get 3x is equal to 6. Then we divide each side by the 3, and we have x is equal to 2. If I have what x is equal to, I can plug it in to solve for what y is now. So I have y is equal to x minus 4. That's going to be 2 minus 4. 2 minus 4 is negative 2. So y is equal to negative 2. I have an x is equal to. I have a y is equal to. So I'm going to form my ordered pair with x comma y. So that's going to be 2, negative 2. For D, we have 2x minus y is equal to negative 5, and 3x minus y is equal to 1. So it doesn't matter which one I choose to solve for y in. I'm going to use the top one just because it's the first one that's there. So I'm going to have 2x minus y is equal to negative 5. I'm going to move my y over to make it positive to get 2x is equal to y minus 5. And then add the 5 to the 2x to leave myself with y is equal to 2x plus 5. And I did that just so that way my terms are positive and I didn't have to do like an extra step by dividing each side by a -1. So now that I have a y is equal to, I can take that expression, that 2x plus 5, and plug it in for y in my second equation since I haven't worked with that one yet. So this is going to give me 3x minus whatever y is, so that's 2x plus 5. Once again, I keep parentheses around that 2x plus 5 is equal to 1. I now can distribute that negative. So we have 3x minus 2y minus 5 is equal to 1. I can combine my like terms to get x minus 5 is equal to 1. And then I just add that 5 over to get that x is equal to 6. I have x is equal to, I want what y is equal to as well. So I'm going to plug this 6 in for x and that 2x plus 5. So we have y is equal to 2 times 6 plus 5. The 2 times 6 is 12, so y is equal to 12 plus 5. 12 plus 5 is 17, so y is 17 when x is 6. So again, I make my ordered pair from this. So I'm just going to have 6 comma 17. For example, E, you have x minus 2y is equal to 7, and 3x minus 2y is equal to 3. I'm going to take that first equation, that's that x minus 2y is equal to 7, and I'm going to solve this for x by adding the 2y to both sides. So I have x is equal to 2y plus 7. This 2y plus 7 gets plugged in for x in my second equation. So this is going to give us 3 times 2y plus 7 minus 2y is equal to 3. From here, we can distribute that 3 into the set of parentheses to give us 6y plus 21 minus 2y is equal to 3. I'm going to combine my like terms here to give us 4y plus 21 is equal to 3. And then subtract the 21 from each side. So 4y is equal to 3 minus 21, which is negative 18. From here, we can divide each side by that 4. And we're just going to simplify that fraction to be negative 9 over 2. So now we have what y is equal to. We're going to plug this in for y to solve for x. We're going to have x is equal to 2 times negative 9 over 2 plus 7. Those 2's are going to cancel, so it's just going to be x is equal to negative 9 plus 7, which is x is equal to negative 2. So I now have what x is equal to. I have what y is equal to. I form my ordered pair out of that negative 2 and that negative 9 over 2 to give my solution of negative 2, negative 9 over 2.